here is a question on functions. We are given two functions. F, the function that takes x and maps to x plus 2. G, the function that takes x and maps to 3x squared minus 1. And we are asked to find f of negative 4 and g of 1/3. Also in B, we are asked to show that the composite function made up of the inverse of f and g takes x and maps to 3 into x squared minus 1. And then in the last section, C, we are asked to find the values of x for which this composite function, f inverse g of x, is equal to 9. Okay, so let's go straight. The function f of x is x plus 2. Okay, this means, therefore, that f of negative 4, all we have to do is to replace x with negative 4 in that expression. So we have negative 4 plus 2. All right, this simply gives us negative 4 plus 2 is negative 2. Then we also have g of x. The function g of x is 3x squared minus 1. Therefore, g of 1/3, we do the same thing. We replace x with 1/3 in that expression. So we have 3 into 1/3. Pay attention, x here is squared. So we square and then minus 1. Okay. Now, BODMAS is found everywhere. So we evaluate the brackets first. So we have 1/3 square. 1/3 square. 1/3 square is 1/3 multiplied to 1/3. Numerator multiplied to numerator, denominator multiplied to denominator. So it is 1 all over 9. And so we have 3 into 1 all over 9 minus 1. 3 here cancels, 3 here 3 times. So this gives us 1/3 minus 1. Okay, 1/3 minus 1. How do we evaluate that? 1/3 minus 1. We can write 1 also as a fraction so that we can see the LCM as 3. 3 divided by 3 is 1. To have 1 minus 3 divided by 1 is 3 multiplied up there. To have negative 2 all over 3. So our final answer is negative 2/3. Okay? That is it for question A. Now, question B says, we should show that this composite function, f inverse of g, all right? So here we have something new, f inverse. So the first thing to do is to find the inverse function of f. Okay, we know that f of x is x plus 2. To get the inverse function, we have three-step method. The first thing is to let y be equal to f of x. From here, we solve for x. So x is y minus 2. Therefore, the inverse function for f will be, we'll now replace y with x, will be x minus 2. All right? So that we can now carry out the composite f inverse g. Okay, f inverse g simply means f inverse is going to carry out its operations on g of x. Okay, now what is the operation of f inverse? If you look at it up here, x here represents whatever f inverse is carrying as its argument. What does it do to it? It subtracts 2. So f inverse is a function that has one instruction. The instruction is subtract 2. So whatever f inverse is going to carry as its argument, it will subtract 2 from it. Here, f inverse is carrying g of x as its argument. So it will carry out the instruction, which is subtract 2 from g of x. So this will be g of x, and we subtract 2 from it. And we know g of x. G of x we know g of x. G of x is 3x squared minus 1. So we're going to write 3x squared minus 1 and then minus 2. So that composite function is 3x squared minus 1 minus 2 is minus 3. Now, if we look at this carefully, 3 is common. 3 is common, so it can be factorized out. So we can write this as, we factorize out 3, 3 into x squared minus 1. Now, if you look at what we were asked to show, we were asked to show that this composite function is a function that takes x and maps to 3 into x squared minus 1. Here we got it, 3 into x squared minus 1. So we can just finally say that f inverse, let's write it up here. So our conclusion, because we should write it in the manner in which the question requires. So conclusion, therefore, f inverse g is that function that takes x and maps to what we have, 3 into x squared minus 1 as required. Okay, now let's look at the third part of this question, question C. We look at question C. It says we should therefore find the values of x for which this composite function is equated to 9. All right. So f inverse g of x equals 9. We know the expression. This expression that is it there. So we are saying 3 into x squared minus 1 equals 9. All right. We are asked to find the values of x. All right. So we have to solve this equation for x. Here we can divide both sides by 3. So that 3 goes off, 3 here 1, 3 there 3. So that we end up with x squared minus 1 equals 3. So we see an expression of degree 2, which is a quadratic. And so we expect two solutions. Again, we should avoid the error. Where someone gets to this level and is tempted to take negative 1 to the right hand side to end up having x squared is equal to 4. And then from here, the person now goes ahead to take square roots of both sides, okay, to end up having x equals 2. That's going to give you just one result, okay? We're supposed to have two results, all right? So this is wrong. So what we need to do here, we take this 3 from the right hand side to the left hand side so that we should have 0 on one side. All right, if we do that, we have x squared minus 1 minus 3 equals 0. Minus 1 minus 3 is minus 4. And so we have s squared minus 4 equals 0. So this is a quadratic equation we have to solve. It's a quadratic equation. Okay, this is a quadratic equation we have to solve. So we can use any of the methods that we know in solving quadratic equations. X squared minus 4 equals 0. So we can use any of the methods in solving quadratic equations. X squared minus 4 equals 0. We can either use the quadratic formula or we use difference of squares identities. So if we choose the quadratic formula, then we collect our terms carefully. A is the coefficient of the x squared term. B is the coefficient of the x term. There is no x term here, so B is 0. And C is the constant term. The constant is negative 4. So if we put it in the quadratic formula, that's the quadratic formula. If we put everything there to compute, then we're going to have negative b, negative 0, plus minus square root of 0 squared minus 4 into a into c all over 2a. Okay, so this gives us negative 0 is simply 0. So we have plus minus the square root of 0 squared is 0. Then we have negative multiplied to negative is positive. So at the end of the day, we're doing 4 multiplied to 4, which is 16. Okay, divided by 2 multiplied to 1 is 2. Okay, this gives us plus minus root 16 is 4 all over 2. And so we have x equals, this gives us what? 2 here, 1, 2 there, 2. So plus minus 2. So x is equal to 2 or x is equal to minus 2. So these are the two solutions for the quadratic equation x squared minus 4 equal to 0. Okay, that's the first method. We could also solve this using the difference of squares identity. Okay, so those who prefer this method, I hope it's well understood. All right, those who prefer the difference of squares method, let us solve it using the difference of squares method. Okay, now the difference of squares, this is already x squared minus 4 is the same as 2 squared. So this can be written as x squared minus 2 squared is equal to 0. So now we have a difference of squares. But we know that the difference of squares identity, we have it as such. Okay? A squared minus b squared is the same as a minus b into a plus b. So your x here takes the place of a and your 2 takes the place of b. So if we write this difference of squares, following the nature of the right hand side here, we're going to have x minus 2 into x plus 2 equal to 0. Okay? Now we have a product of two things giving us 0. If the product of two things gives us 0, if a multiplied to b gives us 0, it means that one of these two letters here must be 0. Either a is 0 or b is 0 for this product to give us 0. So it's the same reasoning we look at when we handle things like this. When we write expressions in brackets, it's like one expression, one item. This one is also in bracket, is like one item. So their product giving us 0 means either this is 0 or this is 0. So we say either x minus 2 is 0, okay, which means x is equal to 2, or x plus 2 is 0, which also means, therefore, that x is equal to negative 2. So here again, we have the same solutions, x equals 2, x equals negative 2.